All right, welcome. So today we're going to talk about undetermined coefficients and the annihilator method. Okay, so we were talking in 6.2, we introduced a little bit about differential operators. So let's just refresh our memory. D equals d dx, okay, is a differential operator, is a basic differential operator. Okay. And what we're going to be looking at is we're going to look at what happens if, let's say, d of f equals 0. So d of f equals 0, for example, that means that f of x is a constant, right? The derivative of a constant equals 0 means the function's a constant. Or the derivative of a function equals 0 means that function's a constant. Let's go another level. Let's say we take d squared f equals 0. Well, that means that, let's take it, f double prime of x equals 0. Okay, so f of x equals c1 plus c2x. Okay, I could keep going forever. dm of f equals 0. That means the mth derivative of x equals 0. And that gives us f of x equals c1 plus c2x plus c3x squared, all the way up to c sub m minus 1. Let me write that a little better. X to the m minus 1. Okay, so that's one of the first things that we can see. Now, let's go ahead and go with the next level. So let's take d minus r f of x equals 0. Okay, well, if we take d minus r f equals 0, that means we're taking f prime of x minus r f of x equals 0. Okay, so f of x equals c1 e to the rx. Okay, let's go another power. Let's go d minus r squared. Oh, shoot, what are we going to do with this? Okay, well, we're going to have to expand first the square. Okay, so just another level before we act on the function, we're going to expand the operator first. So we're going to get d minus r, sorry, actually I'm going to do it a little bit differently. Yeah, no, never mind. So d squared minus, now I can pass the d through the r, no problem. So I'm going to have 2r d, okay, plus r squared f of x equals 0. Okay, so what's that in terms of a differential equation? That means we have f double prime of x minus 2r f prime of x plus r squared f of x equals 0. Now we know how to do that. That's the situation where we had second order linear constant coefficient homogeneous with a double root. So here our f of x is going to be c1 e to the rx plus c2x e to the rx. Okay. Now, we're going to go ahead, we're going to basically do the same thing inductively. So if we have d minus r to the m, f equals 0, okay, the solution here, f of x, is going to be c1 e to the rx plus c2 x e to the rx plus all the way up to, we're going to need 1 power less. So we got c sub m minus 1 x to the m minus 1 e to the rx. Okay, I'm going to write that just real quick in a summation notation. Sorry about that. Let me write it one line lower. So it's going to be k equals 1 to m minus 1, c sub k, x to the k, e to the rx. Okay. All right. And now they do have a list. These are included. Well, actually, these were not included, but this is included. And your list or your chart is right there on page 6.3. I'm sorry, 334 is where I would go. Okay. All right. So that's the basic sort of way that this is understood. We're going to start doing problems in the next video.